The next way of securing inter-service communication is with JWT. So to understand this, we first need to understand what is JWT. JWT is a JSON Web Token, is an open standard that defines a compact and self-contained way of securely transmitting information between parties as a JSON object. This information can be verified and trusted because it is digitally signed. JWTs can be signed using a secret or a public-private key pair. JSON Web Tokens consist of three parts, separated by a dot. You can see three JWT parts here: header in red, payload in pink, and signature in blue. All these parts are separated by dot. You can see dot over here, you can see dot over here. So this left section shows encoded JWT and the right side shows decoded JWT parts. So this red section is a encoded header, which is equivalent to this when it is decoded, and pink section is a payload, which is equivalent to this when decoded, and the last is a signature, which is equivalent to this. So let's discuss these JWT parts. So the first part is header. The JWT header typically consists of two parts. The first is type of token, which is JWT, and the hashing algorithm that is used, such as HMAC, SHA-256, or RSA. So in this case, we are using SHA-256. The second part of the token is a payload, which contains the claims. Claims are statements about an entity, typically the end user, and additional data. There are two types of JWT claims: reserved claims and custom claims. Reserved claims are claims defined by this JWT specification to ensure interoperability with third-party or external applications. OIDC standard claims are reserved claims. We will discuss some of the standard claims in next section. Custom claims are the claims that you define yourself. We need to name these claims carefully to avoid collisions with the reserved claims or other custom claims. You can define custom claims as per your need, like users, department, or role. The next JW part is signature. This is the most important part of the JWT. Signature is calculated by encoding the header and payload using base64 encoding and concatenating them with the period separator. It is then given to the crypto algorithm. So when the header or the payload changes, the signature has to be calculated again. Only the identity provider has the private key to calculate the signature, which prevents tampering with the token. JWT payload section contains various claims. In this lecture, we will discuss JWT reserved claims. As discussed earlier, we can have additional custom claims as well. So the first reserved claim is ISS. The ISS claims identifies the issuer of the JWT. This value is case sensitive and must be a string value. Next claim is sub, SUB. The sub claims identifies the subject of the JWT. This value is case sensitive and must be string value. Next claim is AUD, odd, or audience. The odd claims identifies the audience that the JWT is intended for. Next is EXP. The EXP claim identifies the expiration time on or after which the token is not accepted for processing. Next is NBF. NBF claim identifies the time before which the token is not accepted for processing. The next claim is IAT. The IAT claim identifies the time the JWT was issued at. The next claim is JTI. JTI is a unique token identifier. We can call it a JWT identifier. So you can see these are very short names given to these claims. So this is for the purpose of reducing our payload size when we transfer this code over the HTTP. So we just discussed about the mutual TLS for securing service-to-service communication. Then why need JWT for securing service-to-service communication? Then why we need JWT for securing service-to-service communication? Well, in case of mutual TLS, we authenticate one service to call other service. So we verify identity of services. But what if we need to authenticate end user and pass user context in service to service call? In this case, services themselves don't authenticate to one another. In every request, you need to carry the identity of the end user who initiate the message flow. And end user initiates the request flow. This end user can be a human or a system. The edge gateway intercept the request from the end user, extract the token, and then talk to the authorization server, connected to it to the validated token. Here, our authorization server is acting as a secure token service provider. So you can see over here, the client application makes the request to the API gateway, and API gateway pass the incoming JSON web token to the authorization server. Authorization server validates the token. After validating the token, the authorization server issues a new JWT signed by itself. So here you can see the audience is pointing to starecommerce.com. So we are using the wildcard over here. So after validating the token, authorization server issues a new JWT signed by itself. This JWT includes the user details copied from the old JWT, which is coming from the client application. When the edge gateway passes a new JWT to the upstream microservices, those upstream microservices need only trust this STS to accept the token as valid. When the edge gateway passes the new JWT to the upstream microservices, those microservices need only to trust this STS to accept the token as valid. The API gateway passes a new JWT token issued by the STS in a HTTP header over the TLS to the order processing microservice. The order processing microservice validates the signature of the JWT to make sure that it's issued by the STS it trusts. This is the authorization server we have, which is trusted by the all microservices in our deployment. The order processing service will trust the JWT, which is issued and signed by the authorization server. Apart from the signature validation, the order processing microservice also does the audience validation, checking whether the value of the provided JWT odd is known to itself. When the order processing microservice talks to the inventory microservice, it passes the same JWT that it got from the API gateway. The inventory microservice validates the signature of the JWT to make sure that it's issued by the STS it trusts. Also, this checks whether the value of the audience attribute in the JWT is starecommerce.com. Here you can see the same audience is passed to all microservices with the wildcard. So you'll have your order processing service as orders.ecommerce.com, then shipping.ecommerce.com. When you pass the wildcard, it will be accepted by all the services. So in earlier scenario, you are passing the same JWT across all the microservices. Instead of passing the same JWT across all the microservices and accepting the same audience value at each microservice, you generate a new JWT for each microservice interaction. This approach is much more secure than using the shared JWT. It is called as service to service communication with the JWT exchange. Here we exchange token at each microservices and set the audience to that microservice. So when order service exchange token, it gets a new token with the audience set to the order.ecommerce.com. So you can see here, the client application sends a JWT to the API gateway. API gateway will pass the JWT to the authorization server, which is acting as the secure token service, which will issue a new JWT token copying all the value from the incoming JWT with audience as star.ecommerce.com, and API gateway will pass the same JWT to the order processing service, and the order processing service will exchange the JWT with the authorization server and get a new JWT and get the new JWT with the all value from the JWT and with the audience changed to the order.ecommerce.com, so that when the shipping service receives token from the order service, it knows that it is coming from the order service. For additional security, we can use the JWT with the mutual TLS so that we will have additional security layer.